Good. Okay. So we understand stationary points, points of inflections, maximums, minimums, increasing, decreasing, and so on by now. We have to also understand how they roughly work in terms of growth and decay as well. So there were concepts here, so like this kind of question. There it is, it says continue next week. Example 18. I've said at a point 3 and -2 on a curve, dy on dx is equal to 2, and then d squared y on dx squared, which obviously means y double dash, is equal to -1. Sketch a piece of the curve near P. So what does it actually mean for it to be dy on dx equals to 2? Don't look at the number so much, think of what we looked at last week. So what does dy dx equal to 2 mean to you? Say it again? Yep, that's the better one you want. The fact that y dash is greater than 0, which means it is increasing. Those are the words you've got to use. Increasing, decreasing stationary points, maximum, minimums, points of inflections. Cool? Yep, so let's write that, right? That one's increasing, now you know that. What does y double dash mean? Being -1. Less than 0. Y double dash less than 0 means it's a max. Less than 0, your brain might think minimum, you do the opposite in your head. I might use Ben as an example. I don't know, did you just write that now? I love it. See, he just came in, the first thing he did, he just wrote down y dash greater than 0, less than 0, equals 0. Do it at home. Put it on your wall. Just refresh your memory because that's what you want. You don't want to say y dash greater than 0 minimum. What? Oh, y dash greater than 0 is about increasing, decreasing. Just get your vocab right. Write it 2, 3, 4, 10 times. See how quickly I jump? 2, 3, 4, 10 times. Sketch a piece of the curve near P. It's really easy now, right? We want something that looks like a maximum and it's going to be increasing. Something that looks like a maximum, these are maximums, and it's increasing. Let's see if you guys agree with my answer. This is 3, this is -2, there it is. It's going to be increasing and it's going to look like a maximum. Are you happy with that? Can you see how it's increasing? And can you see it's part of a maximum? Any questions? Numbers are not relevant. No questions? Happy? Happy. You're happy, I'm happy. We move on. Example 19. Again, don't look at it going, whoa. Just interpret what they mean. Novak, y dash, -1, what does it mean? Decreasing, less than 0, decreasing. Y double dash equals 0. Say again? Exponential, you're saying the word wrong. Yeah, inflection. Point of inflection. And you don't need to say it's possible because it actually tells you y double dash equals 0. We only do possible when we're doing the math. When we're doing the math, we write possible and then we have to prove it. But these guys just gave it to you, you just write point of inflection. All good so far? Again, for it less than 2, it says y double dash greater than 0. What does that mean? Nope. Nope. Sorry? Incorrect. Min. No. Opposite of your head. Come on, whatever your head's thinking. If it's bigger than 0, you think max, do the opposite. Min. Less than 0, max. You can't say increasing and decreasing. What word do we use for increasing and decreasing? Y dash, not double dash. Good. All right, here we go. Interesting. So it's going to be decreasing at 2 and a point of inflection. Did I give you the y value? So does the y value matter? Good. It doesn't matter. You pick somewhere. We're just going to pick it there. We're happy? It says it says that it's decreasing. So I think we all know that it's going to be sloped to the left. And it's a point of inflection. Okay. And then before 2, so anything less than 2, it's a minimum, which we know that looks like this. And after 2, it's a maximum, which we know looks like this. So let's see if you guys agree. Can you see it? Can you see my min? Can you see my max? All right. We all agree with that? Yeah. Minimum and a maximum, we can see that happening? Good. Good, done. Your turn. Don't look at the words too much. Remember, you're in advanced math. So it's just about certain little words. And I'm sure you'll pick them up, what they are. Just read, interpret, think about it. Y dash is less than 0. What tells you that? That's rate of growth. What does growth mean in the first? It says the population has been growing. The population has been growing, yeah. So yeah, correct. So rate is differentiate. I agree with that, but it's the rate of growth. So what is growth in the first place? Yeah, I think isn't growth just logically you would say population's increasing? Yeah. So if the rate of growth, the rate of increasing is decreasing, what does that mean? Ah, that's the word we like to use. It's slowing down, and I'll explain that in a second. But this is the way I would obviously see it as well. In 1980, the size of a population was 3,200. The population has been growing. Straight away, when I see that word, I think about it's increasing. I wouldn't think it's decreasing. I think it's decreasing. But then it goes rate, which it's good that you guys have learned that now. It means first derivative. But first derivative of growth. The rate of growth. So the first derivative of growth is decreasing, which means as your population is increasing, it's increasing slower. So there are 2 cases, right? Something can increase fast, something that increases slow. Here's an example, a very bad example, but it's an example. Think of insects. Insects, they will multiply. They can keep growing and growing and growing if there's no predators, there's no stoppage, there's no nothing like that. It'll just keep growing and keep multiplying. It'll increase at a faster rate as well. So it's like an exponential function. Now I introduce poison. And that poison kills off 50% of them. But they'll still grow, won't they? Won't they still multiply? But they're going to multiply at a slower rate. And that's what this means. Yep, so that's the analogy. If the current trend continues, the population will eventually, what does that word mean? Stabilize at a size of about 8,000. In the future, asymptote is the good word we want to get used to because that's what you're approaching, right? Your graph is going to eventually approach 8,000. Now, ready for it? We are at 1980. There we are. We have 3,200 people. There we are. You don't start before it because you don't know anything before 1980. It has been increasing. So we've got 2 things that are increasing. I'm going to label them 1, 2, 3, and 4. You guys tell me, where is it increasing? 2 and 3. Good job. Which one is fast? Which one is slow? 2 is fast, 3 is slow. Can you quickly tell us why you think 3 is slow? Yeah, I like that. Let's just use that word then. I just wanted to see what word you would use. Leveling out. I like that. It's slowing down. It's leveling out. It's reaching its maximum, and then it's going to shoot down. So yes, this is slow. This is going to the sky. It's getting larger and larger. So this is fast. This is increasing at a faster rate. Can we see that? So then obviously it's the shape, right? It's increasing at a slower rate. And then what is it approaching? 8,000. Happy? Very good. And that's what we pretty much missed last week, but then that's what this graph is telling you. Now, I don't want you to memorize that at all. What I want you to do is what I just did with that decreasing, increasing question. I want you to know that if it says greater than 0, y double dash, it's a minimum. If it's y double dash less than 0, it's a maximum. And then I want you to know that if I've got a maximum, where is it fast and slow? Well, this one here is decreasing fast. This one is increasing slow. This one is decreasing slow, whereas this one is increasing fast. Does anyone actually not see the slow and fast? You've got to make sure right now. All good? The point of inflection, this one is increasing. What? Slow. Then increasing fast. Decreasing. Decreasing. So that would be, I don't know, let's think of one. Increasing slow and then increasing fast. Oh, that's a horizontal point of inflection there as well, isn't it? I can't think of one for that one, but I can think of one for this one. This is increasing fast and then increasing slow. So that would be me on a bike. I roll down a hill. I'm going to be increasing, and I'm going at a fast, I'm increasing distance, and I'm going at a fast rate. Then I get to the bottom, now I'm going to climb up the hill. I'm going to be increasing still, but it's going to be bloody slow. Yeah, pretty much. So you'll be up the hill first, and then, yeah, that's it. Done, good. So you're decreasing. You're going back home kind of thing. Come towards home, so you're decreasing distance. Does that make sense? You're not increasing, you're not moving away from it. All good. Done. Good. Like I said, you guys are fast. I thought that would be the case. Let's get to our maximum problems. Curve sketching, we did all of this last week. Last component. Don't underestimate this. This is 99 and 100, right? That doesn't mean it's 90 to 100. I'm saying 99 because we're talking about the best of the best. You've got to remember, Extension 1 students sit this paper, so it's even challenging for them. So when we're talking about 99, 100, we're not talking about the best of advanced, we're talking about the best of advanced and extension kids. So it's going to be hard. Cool. I'll make it as simple as we can. Just don't run away from it. Don't be like, well, this maximum problems, forget about it. That's what I did. But I could do that because I was doing extension 2. We don't have to worry about it as much. For those who aren't doing that, you have to obviously worry about this. So that you guys know, those of you who are doing extension 2, you don't need to stress too much about this. You won't be affected by it. The rest of you who are doing extension 1 in advance, no, this is going to be really, really bad. It is going to be, the beginning's okay. It's the actual HSC questions, your trial HSC questions, they are hard. They are the questions that will differentiate you from your peers. They are the questions that will lock in your top rank. So if you want to compete at that level, these are the questions you want to be able to do. There are only 2 questions that will be really hard in your HSC. One of them is max-min problems. The other one's your superannuation loan repayment ones that we did last time. So on Monday, when the Year 12s are going into their HSC exam this year, their last question will be this. They better get the 10 marks because they usually work about 10 marks. Just maximum problems. So 10 marks of this, 10 marks of sketching graphs. Sketching, stationary points, points of inflections, you guys should be okay with by now. They're not too complicated. You practice a few times, you'll get your head around it. Most of you who have sent me your homework, pretty happy you've done everything right. Yes. You don't, by 8 o'clock tonight, I have to call your mom. Yeah. Yeah. That was the deal.
Give me a second.
You don't need to do it now? I'll give it to you 8:15 then. Trouble.
Wasting my stress.
All right. So, speaking of that, not your homework, speaking of the HSC, next week, when it's on Monday, I'll grab the paper obviously right after it's done. On Thursday, when we hit Tuesday, you guys can see extension 2, but on Thursday, we'll actually go through the advanced paper, so you can just see that you can probably get about 40 marks with the knowledge you have right now. So with the knowledge you're at, think about it, you still have a whole year, you should be able to get 40% just walking in. Cool? Yeah, exactly. Let's go. Max min problems. We did do a bit of it last week. I think I introduced it, but I think we'll just revise it again just to go through this. There are 5 steps there. Draw a diagram, helps when there's no diagram. Your band 6 ones always have a diagram, so you probably don't need number 1. Introduce 2 variables, so you need 2 equations. Form an equation in the 2 variables, noting any restrictions. So like, sometimes it's distance. Distance has to be positive always. I think area has to be positive always. Find the global maximum minimum. So find the maximum minimum of that. So use differentiation. And then number 5, which everyone forgets, answer the question. So I've even been guilty of it. You do a whole lot of math. It takes you a page and a half, 2 pages. And what you forget to do is reread the question and say, have I even answered it? Make sure you go back just before you finalize, before you flip to the next question with these, just answer the question. You'll see what that means. I'll make it easy. Just don't run away from it. It'll take us 3 weeks, I think, for me to be satisfied with this part of the topic. I'm going to reword those 5 steps. I'm going to say it like this. We're going to have 2 equations. 2 equations. Someone no. 2 equations. One equation will have 3 variables or 3 pronumerals. The other equation will have 2 variables. Okay? From 2 variables, you make it into 1 variable. So from 2, you make it into 1. So that means make one of them the subject. So 2 becomes 1 variable. So in other words, I'm just going to write here, make one of them the subject. Make 1 the subject. Make 1 the subject. You'll see it better once we start it. What do you do with that 1 that you've just made the subject? Sub it into sub into here, sub into there. So then you'll have 2 variables. This becomes 2 variables. Once you've got 2 variables, just like y's and x's, let's say, you differentiate, do stationary points, do nature. There is no point of inflection. There is no point of inflection. You do not do points of inflections for real world problems. You don't want to work out a point of inflection, doesn't make sense. You want to work out the highest point or lowest point. That's all you care about. So then stat points and nature. So like I said, it looks complicated right now. That's good. Just keep saying that to yourself. I need 2 equations, 1 with 3, 1 with 2. Make 2 into 1, 1 into 3. 3 becomes 2, done. I need 2 equations, 1 with 3, 1 with 2. Make 2 into 1, 1 into 3. 3 becomes 2, 2, stationary points differentiation, finish it off. So step 1, that step is the hardest step. Once you've got your equation, the rest is everything we did last week. Here we go. Farmer Joe, has 30 meters of wire fencing. She wants to make a rectangular enclosure using the wall of the barn as one side. What is the largest area she can enclose? So that's your barn. There's your X, there's your Y, there's your X. Because it says it's a rectangle and it says area. So that's the diagram I would choose. And it's saying there's already one side that's gone, right? You're using one side of the barn. Any questions so far? All right, I need two equations. What's the first thing, obviously, that I have to write? A. A is, I guess, the first one because it says largest. Largest, what's the word we're using so far instead of large? Max. This is, in other words, find the maximum area. So A equals XY. Hey, look, 3 variables. 1, 2, 3. Now we need 2 variables. What's the other one? I think you said it before. 2x plus y is perimeter. How'd you know to use that? Because they gave you 30 meters of wire fencing. 30 meters must be your perimeter. So there's only what? There's only 3 of them, right? Perimeter, area, volume. That's it. If you ever see those, it's one of those 3. Sorry, not equals P, equals 30. See, look, one equation with 3 letters, one equation with 2 letters. Make 2 letters into 1. Sub 1 into 3, you'll make this 3 look like a 2. And voila. I'm just going to scroll it down and wait for anyone that has any questions. Any questions? Guys at home, any questions? All good? Okay, and then like I said, once you've got that, look, you've got an A and an X. You've got 2 letters. Find your maximum area, just differentiate. You're done. dA on dx, stat points. Stat points. Right? Y dash equals 0. You can't write A dash. I don't care if your teachers write A dash, don't write A dash. In the HSC, if we were marking it and we see A dash, we know you're a poor student. Not good. Don't write A dash. dA on dx equals 30 minus 4x. Make it equal to 0. X equals to 30 divided by 4, 7.5. That's great. You just did some math. Who said it's a maximum? So what must you do? Nature. Because I can, we're just going to differentiate again. dA squared on dx squared equals negative 4. If it's negative 4 straight away, it's less than 0, has to be a. The question said it has to be largest, right? So if you by accident did min, you know you're wrong. Question will have to tell you if it's a max or a minimum. Max. And then, what was the last step that I said don't forget to do? You said sub it in. No, just answer the question. No. Just answer the question. So that's perfect at this stage, usually. Just go back and reread the question. Have you answered the question? What did the question ask? What is the largest area? I didn't find area. I found when that would occur, which is x. I didn't find the actual largest area. So therefore, largest area equals 30 times 7.5 minus 2 times 7.5 squared. Just sub in x into here, into your area formula. You could have subbed it into xy, but that means you would have had to find y, which is 15. Right? 7.5 times 15, technically. Same thing. Which is 112.5 meters squared. Done. So like I said, from stat points onwards, really, it's nothing. It's really nothing. First few lines is complicated to get your head around for the different questions. That's easy. You can understand. That's question 1. You probably won't see in your test. So let's go. Next one. All good? All right. Here, find 2 numbers whose sum is 28 and whose product is a maximum. So what would you do? What's your first equation? Sum is 28. That's what I think as well. So there's your one equation with 2 letters. You need another equation with 3 letters. Three letters. So P equals XY. Product is XY. And that looks like almost like perimeter and area again. Right? The perimeter is 28 and the area is X and Y. That's like maybe 2 sides, just so you guys can see. If I had 2 sides covered and I wanted to fence 2 sides, this would be X, this would be Y. That's exactly the same question, just worded differently. All right, all good. Make this, I'll make X, Y the subject, sorry, sub it into P. I get 28x minus x squared, and then differentiate. So once you've got your 2 letters, P and X, you can differentiate. We're starting to get the pattern of that. You just want your 2 letters. 28 take away 2x equals 0, x equals 14. Again, so what? You haven't proven it's a maximum. Again, what do we do just after you've done all that? Answer the question. It said find 2 numbers. You only found 1 number. Therefore, 2 numbers are 14 and 14. 28 take away 14 is still 14. All good? All right. Why don't you guys try B? Could they be? No. Oh, no, because the sum has to be 28. But good point. Sometimes that would be the case, but then they can't sum to 28. They could sum to positive, negative 28. All right, B. Try that. Just think. Just think. What are the words? What are the key words? What are the key words? I think cylinder and cylinder always is there. Volume, and there's one more. Radius is always there anyway, isn't it? Like you're going to use that in terms of the base radius. That means it has to all be R. That's the word. Area. Now you just found out your 2 equations. One's going to be the area of a cylinder. The other one's going to be the volume of a cylinder. It didn't say volume. You have to realize it's volume because it says cubic meters, exactly like rates of change. Here we go. Volume of a cylinder is pi r squared h. Surface area of a cylinder is area equals 2 pi r squared plus 2 pi r h. The reason why it says in terms of base radius for surface area, look at it, it's so close. What's the only thing you don't want there? For area, look at the area. What's the only thing you don't want there? You're saying 2. No. You don't want h in there. Because it says only in terms of radius. So therefore, you come back to what I've told you. You're meant to have your 2 equations. You're going to make h a subject, so then blah, blah. Everything should work out the same way. So here we go. Volume. Volume is 8600. Bang, bang. Equals pi r squared h. See, 2 letters only. 2 unknowns. Make h the subject. Sub in h into there. A equals 2 pi r squared plus 2 pi r h. 2 pi r squared plus, what's that, 16, 17, 200? I think. Someone will tell me if it's wrong. On R. Yeah, it's all in terms of R. Pi can be there because that's just a constant. 2 is allowed to be there. It's just a constant. Are we happy with that? Again, start from the start. Just read it again, and then look at the working out one more time. Tell yourself, would I have been able to do that? What was in there that Sam did that I couldn't do? Well, seems okay. Just all I have to realize is those 3 keywords: cylinder, volume, and then the area. And because the question says, if you read double I, it says find the minimum surface area, you know that's the one that you're going to differentiate and stuff like that. So that means the volume one had to have 2 letters only. And the area had to have the 3 letters. So the one you're going to differentiate will always have to have the 3 letters. Because that's the one you're going to substitute from the 2 letters into it and blah, blah, blah. Cool. Double I. Find the minimum surface area. We want to find the minimum area to make this shape of a cylinder that can hold 8,600 cubic meters. Why? You guys doing all this math, why? Think about it. If I'm the manufacturing company of this cylinder shapes, I want to minimize my cost, whereas maximizing my profits. So what I can do is go, okay, if I just change the shape a little bit to this, I can minimize my metal that I need to make this silo. If I can minimize my metal, but sell it at the same price as the guy next door, I'm saving money and i.e. maximizing profits, maximizing revenues, whatever it is, bottom line. So the people who use math in the real world, as you're starting to see, are the people who actually need it. So the companies and stuff who actually want to get to that level to minimize and maximizing will do things like this. Everyday person that doesn't need to worry about it will never need to use this kind of math. So if you guys eventually will have businesses for yourself, you would want to learn how to do this stuff properly for the business that you will eventually do, whatever it is. So in this case, let's do it for this one, minimum. We're going to differentiate. I think you guys know what we've got to do. What's the only thing I don't like about A before I start? I don't like that R in the denominator, exactly. So let's just fix that up, and I think happy days. dA on dr equals equals 4 pi r minus 17,200 r negative 2. Yep. What does this equal to? What must it equal to? 0. Stop stalling with that. You actually know by now. Why dash equals 0? It's just like literally in year 9, you learn factorizing. In year 10, you took those factorizing and you made them into equal signs. So that's all you're doing now in year 12. You learn calculus. Now you're going to make all your calculus equal to 0 in year 12. Just trying to say, in year 9 you learn factorizing trinomials, in year 10 you were solving quadratics. Exactly the same thing. All right, what do I do now? When you're going to make it equal to 0. Yeah, solve for r, but what don't you like this time again when you're solving? Yeah, I don't like that. Negative 2 this time. So what are you going to do now? Turn it back. 4 pi r minus 17,200 on r squared. Multiply everything by r squared. And I believe all of you should be able to get the next line in one step. Can someone tell me what it is in one step? Not yet. R equals 17,200 over 4 pi and then cube root. That's it, in one line. Seriously, you don't want to waste more time than what you just did there. Done. Plug it into your calculator, whatever it gives you, that's R. That's what the radius should be to get hopefully the minimum. I say hopefully because we haven't proven it yet. But R is 11.1. Rounded right now. Okay. See, you did all that math. Great. What haven't you done yet? Nature. Let alone answer the question. You haven't done nature yet. See, this is where the problems occur because you feel like you're doing all this stuff. Don't forget your steps. Y dash you just did. Stat points. Nature. All right. I think it's okay to differentiate again. That's what you're going to come up with. The conversation we were having last week, I said, you'll realize when to do Y dash table or the Y double dash. Because sometimes you can look at questions and be like, seriously, do I want to differentiate that again? And it doesn't make sense. But that one, I can differentiate again. Ready? 4 pi, so d squared a on dr squared is 4 pi. Drop the negative 2 down, which becomes plus 34,400. I haven't done that wrong. And then r negative 3, which means over r cubed. You guys just got to trust me with that. Okay, and then what can we conclude? What do we know about r? R is 11. What's 11 cubed? Some number. Divide that number by 34,400, still positive. Plus a positive, still positive. So what can we say about all of that? It's greater than 0, therefore min, which is exactly what you wanted. Now, you can't forget, answer the question. The question did not ask you to find the radius. It said, find the minimum area, surface area. So therefore, min area, sub back in, equals 2 pi 11. Let's just use 11 squared for now. Obviously, you guys would have used your exact answer. I'm going to use my exact answer just so you guys know when I'm subbing it in. I'm not subbing in 11. So if your answer is a little bit different, it's because you're subbing in 11. Okay, the minimum area you can ever get is 2,323.7 square meters of sheet metal that can be made to create a cylinder that can hold that much. It's useful. Imagine I was a rainwater tank company. If I can make the same capacity as the guy next door, but just change my dimensions slightly, I can use less plastic. Think about, I'm not a person that's only selling to like one suburb. I'm selling to a country. I'm selling to multiple countries. That's when the savings add up. If you can minimize plastic usage, same cost as, like I said, the guy next door, or same price as the guy next door. Cool. Oh well, done. HSC question. Very fast. Very good. Again, have a read. From the previous class, they could pretty much do up to triple I. So I pretty much expect the same thing, I guess. Sorry, 9,900, right? This is 9,900 now. It's a HSC question. So it's not that it's hard. You'll see what I mean by 9,900. It is worth 10 marks. But you will see what a 9,900 kind of does. But go. Just at least read, maybe think about it, talk to your neighbor, or to yourself if you're at home. Right, easy, Novak, first one. No, don't do that. You can't do that because that's one thing on you specifically. I know you have a tendency of doing that. You can't. You can't. I guess. I don't know, run away from it or think I can't do it. What if it was in your exam? You're going to try to scap some marks. Reread it. Tell me what's happening. Just maybe explain it. What have you understood from it? Sure.
It costs $1,000 per kilometer to lay the cable along the shore and
Yep, fair enough. 2,600 in under the water. Yep. And the question says, find the total cost of laying the cable from P to R. What would that be? Why can't you see that? Because it says P to R is 5 kilometers. And it says if you're going to go along the cable, along the shore, it's $1,000 per kilometer. And it says if you're going to go in the sea, which is R to S, 3 kilometers, it's going to be 3 times 2,600. Because the way you're reading, I think you read the whole thing, and I think all of you guys do that. So you read, I don't know, 4 or 5 sentences, but this is the way I read. And I'll try to verbally say it out loud. An oil rig S, comma, okay, S, I look for it straight away. I find it. Is 3 kilometers offshore. I get it. So now I go, that's shore, offshore, S is in the sea. So I stop. Every time I'm reading, there's a full stop, I'm stopping. A power station P, I go, P. I look at P now, right, it's all the way there. Is on the shore, right. A cable is to be laid from P to S, right. It costs $1,000 per kilometer to lay the cable along the shore, right. So if I'm on this shore, $1,000, 2,600 per kilometer to lay the cable underwater. So that makes sense because water is a lot harder to lay cable. It's more expensive. That's what I'm thinking right now. The point R, yep, is the point on the shore closest to S. Yes, makes sense. And the distance PR is 5. Yep, so far so good. You understand everything that's happening? You see how I'm breaking everything up? I think you got to do the same thing. The point Q is on the shore. Again, I look at it. Yep, makes sense. At a distance of X kilometers from R as shown in the diagram. Cool. Whereas I feel like I said, you guys, I think you read the whole thing, you look at the diagram, you're like, what the heck am I doing? Whereas I actually break up the word and look at the diagram as the word is describing it. So then I can draw the diagram that they've given me in my head as I'm reading it. It's kind of what's happening. All right, and then I'm like, cool, makes sense. Find the total cost of going from P to R and then R to S. So P to R we said is 5 times 1,000 plus R to S is 3 times, and what's the total cost of that? 6, 7, 8, 12,800. Thank you. 12,800. All right, that wasn't too bad, see? Next one. No, that again, let's try again. Find the cost of laying the cable in a straight line from P to S. What do you do straight away, Novak, when you see it says straight line from P to S? Yeah, but I don't have it, right? So I'm going to draw it up. P to S. Now, what kind of triangle do you see? Right angle triangle. So P to S is square root of 5 squared plus 3 squared. 34. Root 34. And how much would that cost? Root 34 times what? 2,600. Why? Because all under the water. Good job. So far not bad, right? For 9,900. Yeah, good. So how much, sorry, how much money? 1,516. 0. All right, cool, that's okay. So you can see it costs obviously more to just go directly underwater, 15,000 compared to 12,000 for me to go from what? P to R and then R to S. Let C be the total cost of laying the cable in a straight line from P to Q and then from Q to S. Show this. Look at the show. Look at the show. Keep looking at it. Keep looking at it. And now think of P to Q. What value is P to Q? Now look at the show. Ah. And then what's Q to S? Now look at the show. What is it? Square root of x squared plus 9. Keep looking at the show. I've trained you guys enough by now, I hope, to keep looking at the show. All right, let's do it. So P to Q is 5 take away x. This is Pythagoras. X squared plus 9. What would be the total cost? Therefore, cost equals 1,000 times 5 take away x plus 2,600 times square root x squared plus 9. Know that? Now you can do it. You've got to stop not attempting it. Yes? Start it. Let's go for it. You can do it. Done. Heather, all good? Not bad, right? For 4 marks, at the end of the paper, your last question is worth 15 marks. So this is 10, and then there was another one that would be worth 5. Our aim to get a band 6, just to hit 90, is to get half, like 7 or 8 out of 15. So if you've got a 4 already from just baby questions like that, you're cheering. IV. Find the minimum cost of laying the cable. What are we going to do? 4 marks. Tell me the whole thing. Tell me what are we going to do? But no, we already have it actually. Sorry, you said 2 equations. We actually already have the cost function in terms of x only. So this one's already, it's ready. It's prepared. They've already done the 2 equations. They've already made it all, because you did Pythagoras. I'm trying to say you've already actually done all that math. Find stat points, find nature, and then find the minimum cost. Because when you find stat point, what letter are you going to find? Yeah, you're going to find x, because you're going to make your C dash, which we don't call that, but you're going to make that equal to 0. You're going to find x. Good. Stop. Got to make this quick point. Because it's 9900, sometimes your triple I's or whatever they are won't be that easy like this was. They won't be easy because what we've realized over time is most students have a problem with triple I rather than IV. So what they've started to do is make triple I harder, make IV just standard as it's always been. In this case, because triple I was easy, IV is going to be the harder one. So you'll start to realize when when your equation making is easy, then the math for stat points are going to be hard. When your equation making is hard, your stat points are going to be easy. I hope that every single one of my Year 12 students that are going to walk into Monday's exam will attempt the minimum cost or maximum before they create their equations. Because it's at the end of the paper, it will be a show question. It won't be a find question. Because it's a show, the equation is given in front of you. Just go and differentiate it. Bag your 4 marks, then come back up and get your 2 marks. Because 4 marks are more valuable to me out of 6 than 2. I don't want you to say, Sam, it took me 10 minutes to do 2 marks out of 6. That's why I couldn't do the 4 marks out of 6. Get the 4 marks, then come back up and do the 2 marks. So there's no reason why any of you here can't get IV. You have to get those 4 marks. Well, I won't accept it. This one here, because like I keep saying, triple I was easy, there is going to be something in IV, only some of you might be able to get. We'll see. But otherwise, as a general idea, you have to always do IV for me. Like there's no doubt In your exam, you're going to get a question. It's just going to say min max. You cannot come and say I couldn't do it. You know, it's just that points in nature. Cool. Let's get to it. Find the minimum cost. I need some room. So I'm going to bring it here. C equals 1,000. Okay, I think I memorized it. C equals 1,000 IV. 5 take away x. No, plus 2.6 square root x squared plus 9 in brackets like this. I hate that. I'm not going to differentiate that. That looks weird. I'm going to expand 1,000. So it's going to look like this. Come on, I don't waste time. No surds. I'm not going to rewrite it with a surd. I know what I'm meant to be doing. So why would I write it with a surd? dc on dx must equal to 0 eventually. Here we go. Equals negative 1,000 plus 1,300 x squared plus 9 to the power of negative half times 2x. Anyone at home? Any problems with that chain rule? You guys? All good? Right, don't forget, this is the hardest question of the hardest topic of Year 12. If you find this good, we're good. We're going to make this equal to 0. What do you think I'm going to do my next line? Say it again. And then? So you're saying do this 2600x on square root x squared plus 9 first, and then you're saying times it over. Yep. You guys are lucky because the problem that most of you would probably face, Mariette helped by saying plus 1,000 over. If you hadn't plus that 1,000 over, which we won't, I'll show you what would have happened if you didn't do that. It wouldn't be as easy as it just became. Helped you guys. What do we do at this stage? Oh, don't say that one. Don't worry about that. Don't worry about that. Keep going. What did you say? Divide 1,000 as well? Don't worry about that. That's not a big issue. There's a bigger issue. So how do we get rid of that bigger issue? Sorry? Turn it up. Say it again? Yes. The square root. That's an issue. The square root. So what do? Square it. Square it. Exactly. Squared. And like I said, she helped you guys by saying plus 1,000, because if you guys hadn't done that, let me show you what you would have had. 0 equals negative 1,000 plus 2,600x on this, square root x squared plus 9. Then you would have said, let's multiply it. So you would have had this. And then if you didn't decide to bring one of them only to one side, you can't square it, because if you did square it, what's going to happen? What's going to happen if you square the right-hand side? What happens when you square the whole right-hand side? No, you can. Because you got to square the whole thing. No, yet stop doing it individually. What happens when you square the whole thing of the right-hand side? 2 times the inside. You're going to still have a surd. So if you decided to square this now, which is what most students try to do, you're still going to have a squared, which is fine, b squared, which is fine, 2 times ab, you're going to still have a surd. You didn't get rid of it. You're stuck. So the trick to that is obviously you isolate your ugly ones and your good looking ones. So ugly's on the left, good ones on the right, whatever. Oh, this guy. All right. So, all right, there we go. All good. So you have to isolate them. And then obviously the rest is easy now. That was the 9900, by the way. That was the thing that was meant to be hard, which is good. Because a lot of students obviously would be doing the first case that I did, or the second case. And then x squared plus 9 equals 26 squared. 25 squared is 625, so 26 squared is 76. You know how I did 25, you know how I did 26 squared, right? Ready? Something that you guys haven't seen, you haven't put 2 and 2 together yet. You guys have learned a plus b squared, but you haven't learned this, like that. I just did that. I just did 25 squared, 2 times the inside, and I did 1 squared. How do we do 25 squared, if you're wondering? 2 times the inside is 50 plus 1. So I just did 25 squared plus 51. That's what I did in my head. But how do I do 25? Any number like this, 25 squared, 35 squared. I know we're going off on a tangent, but hold on. 25 squared is 25. Sorry. Always ends in 25. So 5 times 5 is 25. And then you just get your first number 2 times it by 1 number higher, which is 3. 2 times 3 is 625. 35 squared is 3 times 4, 1225. 45 squared is 4 times 5 is 20, 2025. 55 squared is 5 times 6 is 30, 3025, and so on. Sussing it out. Doesn't trust me. After all this years. So anyways, I just thought you've learnt perfect squares, but you guys probably haven't put it 2 and 2 together. So if you ever see anybody in the world that does anything fast in their heads, if they've actually memorized the perfect square formulas for them. So like if even if there was, I don't know, 126 squared, trying to do that in your head, you would be doing that as 100 plus 26 squared. Which isn't as hard as you might think all of a sudden, right? Because 100 squared, whatever. But anyways, we'll leave that for another day. X squared, and then I think you guys can see we're going to expand the million, and we're going to be left with 9 million on this side. When you subtract 1 million from here, you've got 5,760,000, and then x equals 9 over 5 million, 9 million over 5,760,000, and then square root it. Oh, a beautiful number. That's when you know you've done it right. 1.25 exactly. All good. Next question? No, of course not. What do we do after stationary points? Nature. Like I said, you'll do all this math and you're like, yes, done. You're not done. Nature.
You just asked to go to this.
I know, but you've got to be ahead of me. Nature. What are we going to do with nature? Are you serious? Look at it. Are you going to do y double dash of this? Yeah, look at it. Look, it's not that bad, but it's bad. Like you got to use quotient rule, right? Look here in this section. You got to use quotient rule. Like, why do you want to do that? I don't want to. So what am I going to do? Y dash table. $1.25 in the middle, 0 down here, 1 here, 2 here, sub in 1, sub in 2 into this. Sub in 1, sub in 2. All right, let's go. Negative 1,000 plus 2,600 on root 10, I think. Negative 177. if it was 2, 2 squared plus 9 is 13, and then that will be times 2, 442. Beautiful. What do we get? We get negative, 0, positive, which is a? If you get a maximum by accident, you know you're wrong because the question will tell you if it's a min or max. It says find the minimum cost. And what do we do now? Once you've done, answer the question. Did you answer it? Have you found the minimum cost?
Yes, we have.
No, you haven't. You found X. You found, this is what you found. Let's just make sure. You found that as long as X is 1.25, you will get the minimum cost. That's what you found. Good. So let's go find what is the minimum cost. Therefore, min cost equals, can you tell me the equation that we had for cost? 1,000. Okay, keep going.
1,000 bracket 5 plus 1.25 plus 2.6 square root of square plus 9.
All right, let's go work out what that number is and see what the minimum is. Root 1.25 squared plus 9 times 1,000. So the minimum you can ever get it to is 12,200. What were the ones above? Let's just quickly read. 12,800. So you just saved $600. And you saved a lot more than double I, but you saved $600 from doing I. And if you think 600 is, oh, that's nothing. When you multiply it to a company size, multiple job sites, blah, 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 it's a lot of money. All good. That's 4 marks. 4. Last one, V. Remember, 9,900. 2 marks is not 2 marks. Sometimes 2 marks is like 4 marks, but 2 marks. Yes, I'm going down. Let's go. Here, copy. Sorry. Let me know when you're finished. Done? All right. And V. New technology. What do you need? Later? Later. New technology means that the cost of laying the cable underwater can be reduced to $1,100 per kilometer. Was that the door? New tech means that the cost of laying the cable can be reduced to $1,100 per kilometer. Determine the path for laying the cable in order to minimize the cost in this case. Okay. What are the different pathways we've got?
SP.
There is, where am I? I've gone too far. There is P to R to S. There is P to Q to S. And there is P to S. So let's work out each one. That's it. That's all you can do. Let's do P to S first. I'm going to do V here. PS. PS was root, what is it? Root 34 times 1,100. Then we had P to R, R to S. Now P to R was 5 times 1,000 plus 5 times 1,000 plus 3 times 1,100. Because it's now 1,100, the same. This one, 8, 3. And what about the top one? 6,414. Blah, blah, blah. And last one, P to Q, Q to S. What are you going to do? To do P to Q, Q to S. No. 1.25 was only for when it cost 2,600. Sorry? No, that's only when cost was 2,600. 9,900. Sorry? I think you just said it. Yeah, start again.
Yeah. It's worth 2 marks.
But it's 9,900. So that even if it's worth 1 mark, 99 to 100 is already hard, let alone just 99 and 100. Right? There's going to be a difference between the person that gets 99 to 100. So it's not that bad. You'll see. You'll see. Just relax. Ready? P to Q doesn't change. Q to S doesn't change. It's just that instead of it being 2.6, it's 1.1. See, it's not that bad. All right, so cost is 5,000 minus 1,000x plus 1,100 square root x squared plus 9. Right? Then we're going to differentiate that. Negative 1,000. It's not going to take that much longer than this. It's only going to take probably 2 or 3 lines more.
I'd rather wipe up.
Go over the wall upstairs.
Dragon said, you get
A different one.
She's fixing x to negative 3, yeah? She's fixing negative 3 over here. And it equals 9. So that means arrow should be pointing right. D. But I knew you were wrong. Question.
So,
We're never wrong. She's wrong.
negative 1,000, please. You guys realize something? Negative 1,000 plus half times 1,100, which is 550, x squared plus 9 negative a half. Make it equal to 0 times 2x. Times 2x equals 0. And then we have 1,100 x on, again, x squared plus 9 equals 1,000. Bring it over. Square it. And what should happen, I'm just going to fast forward it if no one's done it yet. What will happen is you're going to get x is 6.5. What's the problem with that? Sorry? It's larger than 5. Yeah, it's larger than the 5. You can't have that. So therefore, this will never occur. You're never going to get a minimum cost from that one. So your minimum cost is therefore PS. Finished. And that is the 9,900. That's it. So the 99 would have just forgotten about maybe that 6.5, maybe not, didn't have time, whatever. Maybe might not have done it again. The 100 would have just gone all the way to the end. Done it one more time, concluded, it doesn't work, and that's it. All right. Any questions? 10 marks. Let's try. Let me try another one. Let me see if I can find. Oh yeah. All right. Common question in extension 1 exams if they want to test maximum problems. So usually not in extension 1 because it's not an extension 1 topic, but some teachers like to test it just as advanced questions. And did you say we've done this? Is that what you asked? Correct. No, we have. But we have done a very similar one in rates of change. Good. I'm happy you're realizing there's similar. Yeah. Ready? Can we stop talking? The hardest ones you will get are the geometry ones because they don't have numbers. They just have letters. Let's see if we can get these out. A cone is inscribed in a sphere of radius A, centered at O. The height of the cone is X. The height of the cone is X. Yep, I can see that. See how I stopped? I stopped because I understood everything except at that point. Wait, show me? Okay, right, yep. And the radius of the base R is shown on the diagram. And then the question is going to show. It doesn't even give you time to do anything else. It says show V is this. I can't do I. So therefore, I just jump straight away and do double I. It says find X for which it's a maximum. So I know what I've got to do. Just differentiate, make it equal to 0, do my nature, make sure it's a maximum, and then you're done. You must give reasons why your value of X gives the maximum volume. Because I did the math. We'll see. We'll see what happens. Probably there's 2 X values. So we're going to just say this one because this one gives you higher maths. All right. We will do I anyways. I will show you some things you want to know when you're doing these geometry questions. You want to know, because this is what most students usually miss. This is A, right? This is also A. It's good to see that. In fact, this is A. You know, this is A, this is A, this is A, whatever. You guys get it? Like this is A, this is A, this is A, so on. A lot of people don't see that. And some of you are already agreeing, which means, yeah, I'm right. It's fine. I've made you realize it now. Next time you see a question with a sphere, keep in mind that's the logic you'll need. You'll need it somewhere else. The one we're going to need is the first one I drew. I can just see it. That would be A. That would be something with R and A. And therefore, I just found X in terms of A and R and A. See, I found a relationship. I found an equation. So let's have a look. This right here is the square root of A squared minus R squared. So already I can say X equals A plus square root A squared minus R squared. All right, I think it's time for us to read I now. I just think you guys should know that before you do anything. Like you guys know, if you see spheres, usually look for another side somewhere. All right, show the volume of a cone. Okay, what's the volume of a cone formula? 1/3 pi r squared h. 1/3 pi r squared h. Okay, well, we can see it's all in terms of x. So I know 1/3 is 1/3, pi is pi, h is x because the height is x, which means I've got to get rid of r, or r squared. I've got to get rid of r. I've got to get rid of r. Solve for r from the equation above. So I've got to do that. Let me just get these staples sorted. All right. Don't make r the subject, right? That'll be silly. Just make r squared the subject, because you just want r squared. So you're going to get x minus a, you're going to square it. True. And then swap sides. So r squared is equal to a squared minus x minus a squared. And then you might as well expand and simplify that side. So a squared minus x squared minus 2ax plus a squared equals, sorry? Yep, a squared's cancelled out and voila, we're done. We've done it right, and we can see it, 2ax squared minus, yep, perfect. Remember, you guys, this is meant to be the hardest. Oh, don't think you're going to get a different question. This could be your exam question, like in your paper, or in your paper, or in your paper. It actually could be exactly that one. So don't think you need more. You guys just need to practice that one specifically. So don't go out and look for more questions. They don't get harder than these, but you've got to be able to do these. Like, who was it? Whose paper was it that I was looking at? Yours. In your paper was that loudness question that we did. Yeah, so you remember that loudness question we did in rates of change, decibels and stuff. It was in your paper. Yeah, I'm just saying, like, there, done. So you don't need more. You just and here it is again, the loudness question. I'm just saying, you guys don't need to actually look for more. I've given you everything you need. You just got to make sure you can do it yourself. Here's the answers. Just when you go home tomorrow, day after, just repeat it. Done. Double A. If there's no questions, we'll start with double A. What was the volume again? 1/3 pi 2ax squared minus x cubed. Again, personally, it's just a personal thing. Maybe you and your math, you're different. I don't like it factorized. I'm going to expand it before I differentiate. It's all good. 2ax squared pi on 3 minus pi x cubed on 3. Okay. dv on dx equals 4 ax pi on 3 minus 3 pi x squared on 3 equals 0. What can I also do to the pi's? Cancel them, can't I, technically? Pi, no, not because pi minus pi. There's pi's on both sides. When I'm going to make it, okay, maybe I shouldn't do it. Just leave it. Just leave it. If you didn't know it, leave it. I'm going to times everything by 3. There it is. What do you do at this stage? Yes, of course. How? What do you mean? That's the bit. Factorize. Take x out. 4a pi minus 3 pi x equals 0. Therefore, you get x equals 0, or x equals 4a pi on 3 pi. That's what I meant by you can get rid of pi. Rosemary, you probably want to forecast that. You know you're going to eventually solve. If they're both there, you just cross them out, yeah? Because eventually you're going to divide. Done. X equals 4a on 3. Well, question was saying, why choose that x? You know, you must give reasons why your value of x gives the maximum. Well, firstly, you can't choose x equals 0 because that just means it doesn't exist in the first place. So it can only be 4a on 3. You could say that. You could say x has to be greater than 0 for length. All right. Let's just say that. But the reasons, when it's talking about the reasons, it's just talking about nature. As long as you find your nature, it is a maximum. All right, let's do it. What are we going to do with nature? Second derivative or first derivative? I think second derivative is okay. So second derivative looks like this. 4a pi on 3, because you get rid of the x. 4a pi on 3. And then you're just going to get negative 2 pi x. Oh, that's why they want to say if it's a maximum. I got you. Because obviously we're dealing with letters. Keep going. What do we do at this stage usually? What did we usually do? Sorry? Equal to 0? No, that's to find point of inflection. Sub in x, yeah. We had to actually substitute your at. Like, where are you at? We're at x equals 4a on 3. Sub it in. You'll get 4a pi, so y double dash, we'll just write, equals 4a pi on 3 minus 2 pi 4a on 3. Four a pi on 3 minus 8 pi a on 3. What's 4 on 3? Take away 8 on 3. What is 4 on 3? On 3. Right? 4 on 3, take away 8 on 3. Just make sure. Should be, but whatever. 4 on 3 minus, it should be negative 4 on 3. Yeah. Equals negative 4a pi on 3. Now, what must you say? What are we trying to do? Remember, this is less than 0. It's a max. But how can you conclude that? There's something there that they're trying to pick up. You're saying it's a max, which is fine. You must give reasons why your value gives the maximum. Why do you think they're saying that with this? Yes, A. What if A was negative? But what if it was? It would be a minimum. If A was negative, you would have concluded this is greater than 0. It's a minimum now. That's what you have to say. You have to say A is greater than 0. And if you don't say that, then you're not allowed to say it's always less than 0. Because it's not always less than 0. It's only less than 0 because A is always positive. Because if A wasn't always positive, that expression wouldn't always be less than 0. Does that make sense? That's all. You just have to write A is greater than 0. Done. Answer the question like I keep saying. Go back. What did the question ask? Find the value of x for which... Done. We already found the value of x. See how that one you don't need to go back and substitute? Why didn't you bring your charger? Is it USB-C, I think? This one isn't. The charger's this, right? Oh, you got it. Yeah, it's the same. USB-C. You do have a charger. Okay. Okay. Let's keep going. We're doing well. Let's see. Yeah, amazing. All right. Let's see. What's the last one? Primitives done. Okay. I want to pause it there. Wait.